So we still have one presentation left, and the last presenter is Tzung-Chien, and I would like to ask him to share his screen. Oh, no, it's you.
Hello, everyone, and I hope you can see my
it's perfect.
screen.
You can start.
Okay. Hello, everyone. Thanks for having this great opportunity to share my work with you today. So today I would like to talk about the Gestalt, how we utilize the GestaltMatcher approach to overcome the limitations of the rare disorder diagnosis. So as we know that for the last few years, we are already able to utilize the deep convolutional neural network to model a disorder by training on patients' photos. But however, we still have some limitations on this kind of technology for the rare disorders. So, and here I would like to address three main limitations in our study. So the first one is that we don't have enough data for the ultra rare disorders. So for example, for the take Deep Gestalt as an example. Deep Gestalt is the method behind the phase 2 gene platform. So Deep Gestalt needs to train a disorder with at least 7 to 10 patients to model syndromes. So if we look at the figure on the corner here, so this is the prevalence simulations by the ClinVar submissions. So the y-axis is the number of submissions, pathogenic submissions in the ClinVar. And the x-axis here is the disease-causing gene. So here we can see that for more than 50% of the disease genes with less than 10 submissions in ClinVar, it means that we only have very few submissions or we only have very few patients for these disease genes. Then the deep convolutional neural networks such as the Deep Gestalt are not able to model more than 50% of the disease in this world. And the second limitation is that we are not easily to scale up our systems. So for example, if now we want to add one more disease in our system, then we need to retrain our model or retrain our system and re-evaluate our system. And it requires lots of time and also lots of money. And in the end, the last limitation is that we are not able to quantify the similarity between two patients or two disorders. So it is very important to understand the underlying molecular mechanism behind the disorders or the relationship between two disorder or a phenotypic series. So here we present the GestaltMatcher approach to tackle these three limitations. So here, if we look at the figure here, so the upper part is the traditional deep convolutional neural networks. So it trained on patients' photos by the deep convolutional neural network. And the last layer is the classification layer. So we can classify the photos into the syndromes we trained in the model. So for example, here there are 4 syndromes. So the GestaltMatcher approach is that we take, instead of the classification layer, we take the last layer, we take the layer before the last layer as the feature layer. Then we utilize this feature layer, which is the 320 dimensional feature vector. We span another phenotype space, and it's the bottom part of the figure. So in this space is spanned by this feature vector. So each patient is a point located in this space. So therefore, we can quantify the similarity between two patients by the distance between two patients in this space. So therefore, we are able to do the classification for the novel disease or the ultra rare disease, which is not able to be trained in the network, which is not able to be present in the classifier layer here. And then I would like to talk about the most important results in our study, which is the syndromes with the higher distinctive scores tend to perform better. So here we select 50 syndromes. And then these 50 syndromes are graded by 3 dysmorphologies by the 3 scores here, 1, 2, 3. So the score 3 means that these syndromes have the very clear facial gestalt, and it's really easy. it's very easy to diagnose by looking at the face. If the score is 1, it means that the facial features are important, but it's not so easy to diagnose by only looking at the face. So and then the y-axis here is the top 10 accuracy. So we can see that there is a clear positive correlation between the distinctive scores and the top 10 accuracy. So it means that if this we can match the patients with the same disorder, even though this disorder is the novel disorder or the ultra rare disorders in this work. And then later we also implement our approach in the GestaltMatcher.org. So you are able to find our approach like the screenshot below. You are able to upload the patient, and you are able to select some category list here. Then you can see the top 10 syndromes or top 30 syndromes or top 10 patients or top 30 patients, and you are able also to have the 2D visualization of the clustering here and like the screenshot here. So, and we are also recruiting the beta user right now. So if you are interested in our study, you can just write me the email or just contact us. Then we will invite you to our platform. So thank you very much. And I'm happy to answer all the questions.
Yeah, thank you very much. Very interesting. So there is so far no question in the chat. I have the question regarding the ethnic background of the patient. If you have one from Africa or one from remote areas somewhere. So how do you handle this with you?
Yeah, and to be honest, now we haven't have a way to solve this question in our current method, but we do see this bias in our systems. So, but we have so now we have a way to solve it, but we didn't implement it. So maybe I can introduce a little bit here. So now our method to solve it is that we want to introduce another classification test in our neural network, which is to classify the ethnic background. And then we want to make this classifier perform very worse. Then it means that we reduce the features for the ethnic background, but we still want to make the syndrome classification perform very good. So this is our idea, to make the feature unlearn the ethnic background or age bias.
Okay, thanks. There is one question now from Maria Bukhari. She asks if GestaltMatcher is publicly available already so that others can use it. Yes, yeah, it is so.
Yes, it's not really public yet. We will make it public soon. So now we are recruiting the beta user to.
And she also asks, are you considering to add the digital or limb features?
Yes, so this is our next step. We would like to maybe include the hand X-ray or fundoscopy into this whole system. This is a final goal.
Okay, thank you for answering these questions.